Welcome to this video, great to have you on board. In the last video we added user sign up, so the functionality to create users. In this video I want to make sure that users can also log themselves in and get such a token I was referring to in the last video. The token which we then need to attach to future requests which reach our protected routes on our backend. We don't have protected routes yet, we'll add these later, but for now let's make sure we can get such a token at least. So that is what we'll focus on in this video. Time to create some tokens. In our user routes file, we got a sign up route. Now I want a second route before I delete users, where I also handle post requests, but to /login. And the idea here is to also get email and password, but not create a new user, but instead have a look at the database and see if we got a fitting user, and if we do, then actually create such a token. So here, first of all, I'll create response, request, response, and next. And the goal here will be to see if we got a user. So I can use my user model and simply find any user for a given email address. So where email is actually equal to request body email. And that approach is pretty similar to the sign up route, where we also find such users, in this case to make sure we don't create a new user for an email that has already been taken, in this case down here, in order to log the user in. So here we then have exec to get a real promise with then and catch. And now for catching, I'll use my default error handling code. And yes, we could outsource this into a separate method. I might do this later. For now, let me stay to this more verbose but also understandable way of coding this. Now the then block is of course interesting to us because that is where we get our user. And to be precise, we should name this users because, as you learned, this will be an array. It's just an empty array if we got no user, and I'm naming it user because it will at most be one user because we prevent the creation of duplicate entries due to our check here in sign up. So I get my user array, and therefore first of all I'll check if user length is smaller than 1. So if we got no user. If that's the case, then I want to return a response where I set a status code of 404 and basically tell the user that login failed. However, this might not be the best pattern, because what we could do is we could send a JSON response where we send a message like mail not found, user doesn't exist. Whoops, doesn't exist. Like this. The issue with this approach is that we open our app to some kind of brute force attack. Users could now just try out different email addresses, and they will at least find out which ones are there and which ones are not. So once they got a list of available email addresses, they could focus on these to then get out the password or things like that. So this might not be the best pattern. Not a super big flaw if we add it, but also not great and can be a big flaw. So let's not do it like this. Instead, let's just return 401, which simply means unauthorized. And I'll also simply return auth failed, which could fail because we got no email or because the password is wrong. So that's the first check. Now let's assume we make it past this if block here, so we don't return this response and therefore this code gets executed. Now we found the user. The next step is to make sure that the password sent with the request matches the password in our database. The thing just is, we do hash our password here with bcrypt hash. And in the last video I mentioned that we can't reverse this. So how can we match the new password, which is coming in plain text, to the password in our database if we can't rebuild it? Well, bcrypt of course used a certain algorithm for hashing the password. And we basically have some kind of way of comparing values, even though the hashes won't be the same, just by making sure that a plain text password, which we hash again with the same algorithm, in the end yields us a comparable hash. So this is a check this package can do for us. And you can dive into the bcrypt documentation on the GitHub repository to find out how this works here with this compare method. For this, we need to pass the plaintext password and the hash we want to compare it to, and it will return true if it basically finds out, yeah, both passwords were created with the same algorithm, the same key, and therefore they are the same passwords, even though the hashes don't match. So this is what we can do here. So in my part here, after checking whether we got the email, I'll use bcrypt again and call the compare method. And first of all, pass request body password here, the plaintext password. And then the hash, which is of course part of the user we retrieved. So user, and then here we can simply access the first element. And by the way, an alternative to find would also be find1. This would ensure that we don't get an array, but just one user. I'll just stick to this general syntax, but you could definitely use find1. So here we have user 0, and this is the only user we found. This user will have a password field. We stored this in the database because our user model has a password field. Now with that, we can compare these two. And now the third argument here is a callback where we get an error or a response. Now an error is not returned if we can't compare these. It's just an error we get if the comparison generally fails. So if we got an error here, I simply also want to return off failed. Don't need to pass more information than that. If we don't have an error, I'll check if response, because if that, excuse me, shouldn't name this res because that again is our res object. So let's name this result. So I'll check if result, and as we see in the official doc, this is just true if it succeeds or false if it fails. So what I can do here is I can simply check if result. So this will be true if it succeeded. So if the password is the correct one. In this case, I will return a response where I set status code to 200. And then I return my response where I say off successful. And of course, the token is still missing here. I'll come back to this. I also need another response here at the very end. If we don't make it into this if block here, then we return all failed because then the password was incorrect. And we always return the same error code and message to give no indication about whether authentication failed because of a wrong password or an incorrect email address. And with that, we got this set up. We should now be able to give us back this off successful information. Let's now save this and try it out again. Back in Postman, I did create a user with test3@test.com and the tester password in the last video. So let's now target /login, which is the route we created here. And let's send the same information and we should get back off successful. Now if I change the password and add one extra R, we get all failed. And the same if I enter a password and email which doesn't exist. We also get all failed then. And if I revert this to a valid combination, it again is successful. So this is working as it should. Now, we're not done yet though. We want to return such a token, don't we? Now for that, we'll add another library to our project, Node.json Web Token. It's a library that will do this token generation and signing and so on for us, which of course is a bit of a more complex process. And we simply have to install it and then follow the usage instructions down there. So to do that, I'll quit my process and run npm install JSON Web Token. I'll also add --save to add an entry to package.json. And now this will execute and will add this token to our project, this package to our project. I'll restart the server thereafter. And now how do we use that? Now you see here we got a couple of methods like JWT sign, and signing actually is what we need to create a signed token. There you'll see we pass a payload, so some data we want to pass into the token. We then pass a secret key, so that is the key which only is known to the server. And we also can pass more options and a callback that is executed once the signing is done. And in the options, you can choose the algorithm, though I will keep the default, change how long the token is valid. This shouldn't be too long for security reasons because the token is stored on the client, and if the client somehow is insecure and someone steals the token there, he got full access to your API. So you want to make the token short-lived. And these are a couple of other things you can define and add. The default should be fine. I'll tweak expires in though, and I will also make sure that we will sign the token to begin with. So you can also see some usage examples down there. To create a token, let's first of all import this package. I'll name it JWT and require JSON Web Token. That's the package we just installed. And then in my login route here, if we got a user, so here when we return off successful, I will actually use JWT and call the sign method. Now here, first of all, the payload. What do we want to pass to the client? Maybe we want to pass the user email address and ID. Certainly not the password, even though it's hashed, but don't do that. So I will add an email here, email key, and this will of course be my extracted user email. So I can simply access user 0, which is the user we got from the database, and there the email field. And now the same for the ID. User ID can be user 0 and then underscore ID. So these are the two values I want to put into my JWT, so in my JSON Web Token. Then we need a private key. And I'll again use an environment variable for this. So I'll add it to my environment variable file. There, along of my, or next to my Mongo Atlas password, I'll add my JWT key, and I'll name it secret here. Obviously, you would typically use a more elaborate string than that, but I'll just use that here. And then I will use it here too. As a second argument, I'll access process.env.jwt key. So that environment variable we just added. Now, let's continue adding arguments here. The next argument are the options. So I'll put this into a new line here, and then another new line will be a JavaScript object where we can define the options of this signing process. And here I'm interested in the expires in field. And this can be set, as you can see in the documentation, to a value in seconds or a string describing time spans, like 1 hour. And 1 hour is a good duration for security reasons. And finally, the last argument here is a callback where we get our token. You can, however, also omit this callback and just assign it to a constant like I do here, token, and it will then run synchronously and give you that token. And with that, we can return the message, but also the token here, which is stored in this token constant. And now if we restart the server, since I changed the environment variables, if we go back and we again log in for this valid email password combination, I get back off successful and this token. Now if we copy that token and I go to jwt.io, a link to which can of course be found in the video description, but I guess the URL also isn't that hard. There we can scroll down and copy in our token. And this will now give us a decoded value because remember, it's not encrypted, it's just encoded in a base 64 string, but it's not encrypted. And this is what's inside our token: the email address and the user ID, expiration information, the algorithm which was used, and some verification information, which in the end will be used by the server to verify it. And if we were to change anything here, like let's say change the email, you'll see the token on the left also changed, and therefore it wouldn't be verifiable by the server anymore. You see that the verification, the blue part here, switches if I switch that. So that is what ensures that our token stays valid and we can't fiddle around with it. So this is how we now add a token and return it to the user, to the client. In the next video, we'll actually use that token to then also send it with requests to resources we want to protect. You'll learn how we protect such resources and how we can verify the token.